Welcome to lesson 15.1, defining and evaluating a logarithmic function. In this lesson, we're going to learn what is a log function. Log is just short for logarithmic. And right here on the first page, if you turn to page 745 in your book, you're going to find out that an exponential function, let's say 2 to the x power, all right, that we actually have an inverse for that. And a log function are inverses of exponential functions. I have an example of a log function written here at the bottom of the page. And the way you read this is you read it as log base 2 of 32. So log base 2 of 32. So if I had, let's say, log base 5 of 25. All right, so that's how you read that. So let's just take a minute here and see why we need to learn about logs and how important they are. If we had this exponential growth function, we put $200 in the bank, it had a growth percentage of 10% each year, and we want to know when will it reach $1,000. So we divide both sides by 200. So now I have this 1.10 raised to the t power equals 50. And at this point, all we know to do is to put this in the calculator and guess at this exponent. And you could do that, and the answer is actually between 41 and 42 years. So 41 is too low and 42 is too high, but the time is somewhere in there. But most of the time, we want an exact answer for this time. And in order to find that, we need to use logs to solve this exponential equation. So that's where we're going with this. At first, we're going to learn about how to write logs and how to graph them, and then we'll eventually get to using them to solve exponential equations. If you'll turn to page 746, this is a really important piece of material, this concept here. You can rewrite any exponential function as a logarithmic function. And you can do that in reverse. You can take any log equation and rewrite it as an exponential equation. So we're going to take a look at how do we do this. So let me point out a few things here. Notice the base is going to stay the same. Okay, we have a base b in our exponential equation. The base b does not change, whether it's exponential or log. Okay, b stays the same. All right, our input for the exponential, which is our exponent, becomes the output of the log. The output of the log becomes the input for the exponential. The output of exponential becomes the input for the log. So hopefully you see how the base remains the same. This will help you write these when we start writing them. Base stays the same. Input goes to output. Output goes to input, and vice versa. So let's try some of these. On page 747, we have example 1 with a table, and I believe the table's worked out for you down below, but let's not look at that. Let's just look at this table and see if we can rewrite these ourselves. So I'm going to start with an exponential equation, and I want to rewrite it as a log equation. Okay, so first thing I'm going to write log. Okay, the base stays the same, so base 4. So there's my base 4. All right, the output becomes the input. So the 64 goes here. The input, which was 3, becomes the output. Well, let's go in reverse this time. My base is this number 5, so that becomes my base. The output, which is -2, becomes my input. The input over here becomes my output. And you can actually see that that makes sense, that 5 to the -2 power is 1 over 25. All right, let's try another one from exponential to log. Log, my base here is 2/3. Now you don't see that too often, but it could be a fraction, log of 2/3. Next comes the output, becomes the input, so that is of Q equals P. Let's go in reverse. Start with your base, which is 1/2. So I'm going to put that in parentheses. The output becomes the input. The input becomes the output for the opposite. And that's how we can go about rewriting exponential as log. And that's going to be a really important process that you need to be able to do. So right below that we have example B. So let's see if we can change these. Again, from exponential to log. So log base 3, the output 243 becomes my input, and vice versa, and that becomes a 5. Let's go in reverse. Start with your base. Okay, your base is that small number on a log. Base 4. Raise to the -3 power, so there it is, the output now becomes the input, equals, here's my input, now it becomes my output. So I'm hoping that you can see how these are inverses and how the numbers move from being an input to an output to an input. And that's almost kind of the definition of an inverse, where we're swapping the x's and y's, but rather than x's and y's, here we're swapping, we're just using the words input and output. All right, let's try this next one. Changing this one to a log. We're going to have log base 3/4 S equals R. Okay, you try the next one. I'll give you a minute to write it down as an exponential equation before I put the answer down. All right, check your answer. Did you have 1/5 to the W power equals V? All right, turn to page 748, your turn. I want you on your own to complete the table by writing each given equation in its alternate form, and we will check these in class together.